Hello everyone, I am Paul, your e-hobby guy. These days so many PCs are thrown away because they're old, not working. In most cases I find that the power supplies are still good. Usually there's only 4 screws holding them in, and so we can easily scavenge old power supplies like this one that I scavenged. Here's another one I grabbed out of a PC that was being thrown away. And here's actually a brand new one that somebody was just throwing away, and so I got it for nothing. This one is actually a 600 watt, which I think I'm going to use because it's got a lot of power. And these power supplies can be converted into benchtop power supplies with the use of this breakout board. It's an ATX power supply breakout board that breaks out the power from all of the wires in the main Molex connector into binding posts and gives us 3.3 volts, 5 volts, a plus 12 volts and a minus 12 volts around a common negative. The 4 sources of power are fused and there's an on-off switch here. We're going to do a review of this breakout board, see if it does what it's supposed to do, look at the pitfalls of getting something like this. This was only $8 on eBay, and I'll show you what I found and what to look out for and how I put it into use. So let's jump right in. First we'll take a look at the power supply. It has a standard on-off switch, a standard 3-pin power connector, and field selectable for 110 volts AC or 220 volts AC. So let's just take a look at the specs for this power supply. We'll freeze it right here. We are getting for the 3.3 volts, a whopping 20 amps we can get out of this power supply. At 5 volts we can get 28 amps, which is quite amazing. For 12 volts, 36 amps, and on the minus 12 volt spec we're getting just over half an amp, 0.6 amps. So this is definitely a great addition to the power supply that I have. It can give me a lot more power if I do need it on bigger projects, and so I'm very happy to add this to my tool set. And now looking at the breakout board itself, I did notice that the binding posts were coming loose simply just by me loosening them and tightening them, and so I was a bit uncomfortable with that. It didn't have any lock washers, and so I decided to remove the binding posts and lock them down with some liquid thread lock. And so that's exactly what I did, and so here you can see me removing all of the binding posts one by one. And while I had them all off, I also took advantage of having it on a flat surface that I could mark it out and possibly make it and mount it into some sort of a wooden box. So I marked out the mounting holes while I was able to lay it on a flat surface. And so here I am replacing all of the binding posts, but using liquid thread lock to make sure that everything is held tightly in place. And so just checking the voltages here on this breakout board, we got 3.363 on the 3.3 posts. We got 5.17 on the 5 volt and 12.52 on the positive 12 volt. And on the negative 12 volt we have 11.49, which all acceptable. I just wanted to check those before I committed to making a box of some kind. And here is the 12 volt plus to 12 volt minus 24 volt potential difference between those two. And so I did decide to go ahead and just make a wooden box, something to hold it steady, because it is just a little loose. So I marked a piece of 3" by 1/4" poplar, about 7 inches long, and so I was going to make a front, a top, and 2 sides. And so I just used a simple miter box and miter saw to cut the 4 sides and the top. I used my rotary tool to create a hole in the top so that I could use my coping saw to make the cutout for the binding posts in the top. I did cut the top down at an angle of 22.5 degrees to make it slanted slightly towards me so I could see the top of the breakout board. And then I just used simple wood glue to glue everything together. And this is what it looks like all glued together. All that's left to do now is to paint it to make it look a little better. And so here it is painted black. So it's a very simple matter of using 4 small wood screws to screw it in place right into the top of this housing that I just made. And so next and finally I wanted to make some jumper wires that would bridge the power supply to the breadboard so that I could actually use it to power my projects. And so I used a simple male header cut in half, and I used some simple hookup wire to extend each of the red wires and the black jumper wire from the power supply to what would be the breadboard to power my projects. And so everywhere I made the extensions, the wires were twisted together, they were soldered and heat shrunk. The spade connectors that will go under the binding posts were also crimped onto the wires and soldered to fit snugly under the binding posts. And so here they are, fitting nicely under the binding posts, ready to be bridged onto a breadboard for any project where I might need it. And so in conclusion, this breakout board is a very handy tool to have in your toolbox, along with a power supply that you can scavenge from an old PC or even buy. The power supply itself can actually be hidden under your desktop, which would make it even handier to cut down on clutter. That's it for today's video. Remember to rate this video up and to subscribe to my channel to be automatically notified of upcoming videos. I really hope this video was helpful. Be sure to follow me on social media. Thank you for watching, and I'll see you next time.